Alright, so imagine there are two users connected to our server and they wish to chat with each other. The first user types in hello and this has to travel somehow across the Node.js server to the other user. Then the second user types in a response and this comes back to the first user. It is interesting to see this process as analogous to a phone call where two entities are communicating seamlessly and without breaking the connection. However, we must remember that HTTP is stateless. This means that when a web page or technically a client requests or sends some data to the server responds back and that's it. The connection is severed and both the client and the server have no bearings about each other till the next call is made. Imagine a police walkie-talkie where communication happens in a single direction. When one person speaks, the other listens and only after that, the other person responds. But besides this phase, there is no active connection between the two radio sets. This is quite unlike a mobile phone call where two users stay connected across a seamless pipe as voice flows bidirectionally and simultaneously with ease. This means that in our client-server model over HTTP, we can send a request from a client to the server, but there seems to be no way for the server to independently reach out to a client if it had to. So the questions we must ask are, how do we get the server to push data to a client if and when it wants to? And how do we keep a connection between a client and a server open and connected at all times so that data can flow in either direction with ease and without specifically seeking out a connection? Now, one of the ways is long polling, where every client requests an update, usually through AJAX, and as soon as the server responds back, a new request is sent and the cycle keeps on going. This way, the client tries to stay in pseudo sync with the server and the server keeps responding back. This is obviously not very efficient, but it works to get the job done. So, in a nutshell, client requests an update to which the server responds back. The client then receives this data and sends another request for an update. And the cycle keeps going on and on. A better and a more modern way is to use WebSockets, which enables both our client and server to keep a connection open and working over a single TCP socket. This is achieved by using the WebSocket WS or WSS protocols. This type of communication is asynchronous and enables both the client and the server to push data and messages across without connecting and breaking connections every single time. To implement WebSockets in your apps, perhaps the most popular of all implementations is SocketIO. To put things in perspective, SocketIO is not a protocol in itself, but is an API that implements WebSockets on both the server and the client. This is with an ability to fall back to AJAX-based long polling if WebSockets is not available, as in the case of older browsers. And it's not just about Node.js and web browsers. SocketIO is available on a wide range of platforms, from iOS, Android, C++ for embedding on devices, to Java and several other implementations. The latest editions of SocketIO for Node.js implement automatic data compression for optimal speeds, and it also has the ability to detect disconnections, in which case it attempts to connect again. A feature that can save your app and the entire user experience in sketchy situations such as on mobile devices where network connectivity is never guaranteed. And data is not lost. If the connection is unstable, then SocketIO will buffer up the data and will transmit when it can. Best of all, it is amazingly simple to use. And this is how it works. The client first attempts to contact the server using either AJAX or WebSockets, whichever is available. It is also at this time that this transport medium is locked down since older browsers do not support WebSockets. Now let's say we are in the WebSockets mode. The client then attempts to perform a handshake with the server. This is done over standard HTTP first. When SocketIO on the server handshakes successfully with the client, the HTTP protocol is upgraded to WebSockets and a session or socket ID is assigned. At this time, a transport socket is created and opened. Using this channel, both sides can then send data continuously. To ensure connectivity, SocketIO sends heartbeats which work like pings to ensure the other side is connected and alive. This lets SocketIO detect disconnections, in which case it attempts to handshake again and keeps doing that till it gets an active connection. SocketIO also uses an event-driven mechanism. So in a chat application, for instance, SocketIO on the client would send an event and we can name the event whatever we like. Here, for instance, I'll call the event message EVT. An event carries along an optional body, which can contain data that it needs to take along. This can be anything from JSON to even binary data in the case of a video chat application, which would send image data along. These events are then received on the other side, let's say on the server, where you can then act on them as you like. When the server wishes to respond, it can send along an event which can be read in an event listener on the client and acted upon as needed. Either way, the use of events and event listeners makes everything asynchronous and easy to understand. Now, while SocketIO works with any framework and even without a framework as far as Node.js goes, we are building our application using Express. So it would be good to understand how SocketIO fits into our workflow. At the very center is our Express app instance, which implements its own server. For SocketIO to work along, we will first create an instance of Node.js's HTTP server using the HTTP module. This would be used to replace the internal Express implementation of the server instance because we want raw and direct control on this instance. By instantiating an HTTP server class, we can bind our Express app to it. SocketIO then binds and embraces this HTTP server instance so that it can listen in deeply to the communications channel and can take control of the protocol level implementations of WebSockets as necessary. Having discussed this theoretically, let's actually go ahead and implement SocketIO in our project.